let us take a look at the very first Excel model we've built. I made a little bit change in this sheet by inserting a column that labeled each laptop as 1, 2, 3, 4, 5, just for the sake of convenience of discussion. Again, of course, if I do that, so the formulas are adjust a little bit in here, and the ratio. This ratio is not the optimal one. It's just a ratio of category 2 divided by category 1 in our case. This model is actually solved. So this is the DMU5. When I say laptops are usually called decision making units, I say sometimes I say DMU5 or laptop 5. So when you look at the weight that you get in here, and you see two zeros in here. So the question you may ask is that does that mean the two measures, in this case the battery life and the HDD capacity, are not considered for this particular laptop number 5, although it achieves a maximum ratio of 1, which means that is the best practice laptop? The answer to that is not necessary. Okay, on the surface, it appears that the battery and the HDD capacity are not included in the calculation of the ratio because of the zero weights. However, there are numerous possible weight combinations that yield a ratio of 1 for laptop 5. Unfortunately, Excel solver only finds one of such weight combinations. Then you may ask, well, then is there a way to find a positive weights, or to let Excel to generate possible weights for all the performance measures? Unfortunately, the answer to that is no. It's not possible to do that, to let Excel to generate all possible weights. However, if you look at this result, this is when the first DMU is on the evaluation, and if you take a look at the ratio of the category 2 divided by category 1, now the ratio is 1. Then that means under this particular set of weights, laptop 5 is a best practice. Okay, so this set of weights or this set of weights will all give a ratio of 1. So this indicates that sometimes you may be able to find out a set of positive weights for some other laptops, and that weights will give you the same maximum ratio. So this example again illustrates that you actually have multiple sets of weights that will give you the same ratio. So this is the ratio when the laptop 5 is on the evaluation, and this is the weights when laptop 1 is on the evaluation, but both sets of weights gave a ratio of 1 for laptop 5. However, there are ways you can force the Excel solver to produce positive weights. One such way is that in the solver you can add a constraint saying that all the weights has to be positive. Now, in the linear programming, you cannot say something is positive. The constraints had to be greater than or equal to, so the equal sign is always there. So what you can do is that you can add, say, this is the constraint in there, saying that all the weights in there has to be greater than or equal to a very small positive number. Okay, so once you solve that for the MU5, and you get everything that is positive. Another way is we actually can incorporate some kind of user preference over these performance metrics. Now remember, the basic assumption in this model is that we will let each laptop to pick the weights on their performance metrics. However, what if, as a user, that you think the battery life is at least 3 times more important than the weight? Okay, so in this case, you will say, this weight should at least be 3 times bigger as this weight. And in the Excel solver, we can actually incorporate these kind of user preferences into the model. And here's how. Okay. So you go to the solver, you add this constraint. This says F20 is greater than or equal to 3 times D20. So by adding that and you solve it, okay, so this is the same VBA code, because this is a new Excel file, so I sort of copy and paste that over. So again, the results are all reported in column O, and so this is the results that you get. Okay, as you can see, under this particular condition, the additional condition is saying that the battery life is at least 3 times more important than the weight. Under this particular condition, that these are the ratios. If you pay attention to the ratios, as you can see, many of the maximum ratios are actually decreased when you compare that to the original problem without that additional constraint of the battery life is at least 3 times more important than weight. This technique is called adding weight restrictions or adding user preferences into our analysis. So as you can see, this particular methodology, it is very flexible. You can let each laptop, in our case, to pick the weights, or on top of that, you can add additional restrictions into the model.